Hello, my name is Darsh, and today we are going to be showing you our LEGO EV3 Mindstorms cleaning robot. I'm going to be showing you our cleaning robot along with my friend online on Google Hangouts. Hey Troy.
Hey Darsh. Hello, my name is Troy, and today I'm going to help demonstrate our dirt cleaning robot developed from the LEGO Mindstorms EV3 computer. It's a LEGO robot that uses a brush drum to collect dirt. The dirt collects in a pan on its back and later dumps. Back to you, Darsh.
The reason we made the cleanup robot was because after I was done playing with the Legos, my parents told me to clean it up, which was the most boring part. So I made the cleanup robot. Now I'm going to be showing you the pieces and parts of the robot. So this is the robot. It's a Lego robot. It's a Lego. All these parts are from Lego. The software we used is LEGO EV3 Mindstorms. It's a freely downloadable software from Lego.com. And now I'm going to be showing you the parts. So this is the main brick, the EV3. It's a small computer that has its own input and output ports. The input and output ports can drive such as motors to sensors. So this is a motor. These are motors, the orange and white ones. This is an UltraSonic Sensor, also known as a Sonar sensor, and this is an IR sensor, also known as an Infra-red sensor, and this is a color sensor. So what this motor drives is that it moves this drum motor, which we built from these $1 scrolls. And we cut the bristles from it, and then we glued them with hot glue and cardboard. So this motor drives the drum motor through these gears, and this motor drives the dumping tray, which dumps it when the tray is full. Now I'm going to show you the robot in action. So I'm about to run the program, and okay, so this is stage 1, the cleaning stage. This sonar sensor is active for anything. It's scanning the environment for anything that's in its way. If it finds anything in its way, it'll back off and turn around. And it does it for about 15 seconds. And now 15 seconds is over, so it's in stage 2. It's looking for the IR beacon. And it just detected the IR beacon because it gave out a sonar sound. Okay. So now the drum motor's inactive, and now it's in stage 3. IR follower stage. This sensor is active, and so is this sensor. Now it's in stage 4, line follower stage. It follows the line until it detects this red dot. Once it reaches this red dot, it'll turn around, reverse, and then turn around again and reverse here, and then it's going to dump over here in this tray. Like so. And that's your program. So now I'll show you the code. Come on over here. I'll show you the code for it. Okay, so this is the main program. This is the main program. We're using the modular programming method, which has modules in it. So we have 5 modules. In LEGO Mindstorms in EV3, it's called My Blocks. So this is the first my block. So if I double click on it, it shows me the code behind the my block. So what the logic is behind this code is so right here it's saying if it is less than 25 inches, it will change its action, and it repeats that for 15 seconds. And at the same time, it's moving this drum bristle, which is also for 15 seconds. And then the next module is rotate until IR found. So as you saw, it was rotating, and then once it detected the IR transmitter, it moved to its approximate direction. So here's the code for it. The code over here is that if it is the logic behind it. This is like if it is equal to 25, it will change its action. So in this case, it's rotating, and then it does it for 10 seconds, and then back to the main program, and then it's line follower. So over here, the logic behind this one is so first, how we got our threshold value is first we kept the robot on the black part of the mat, and then we got the value of 6, and then we kept it on white, and we got 56. So then we wanted the border, and the border value was 25. So that's why we kept 25. And the value 25 drives the motor, and it's in a loop for until it finds the red tape. Okay, and then that's your program. Now we are gonna be answering some of the hypothetical questions you might be having. In terms of parent involvement, my parents gave me a lot of motivation, and they also helped me make the front drum motor, which sucks in the trash, which includes a hot glue gun.
It was.
In answer to how long did it take me to create this project, it took about 2 weeks to make the actual robot, and then several other weeks for programming, debugging, and of course testing and integration testing. Back to you guys.
So the most easiest part was, for me, the ultrasonic cleaner, because I was pretty familiar with the IR beacon, ultrasonic sensor, like the Sonar sensor, and it was easy coding for me because I already had a lot of background knowledge with it. And then the most challenging part was the IR beacon and the IR transmitter with the infrared sensor, because I didn't really know it was there. Like, I didn't even know it existed, so it was pretty hard, like, doing programs with it. And then
Troy, next question.
Oh. In answer to what was the most fun for us, the most fun was when we designed the IR beacon, because we played around with it like it was a pet dog.
Okay.
Back to you guys.
So what I learned from this project is that I learned the different aspects of programming, the different aspects of robotics engineering, and the hardware design, and the testing during integration. And how would I take this project further? We would expand it to airports and large homes as an application, and also we could switch the drum motor to a blade. So in this case, it could be used as a lawn mowing robot. And now, thank you for listening to us.
Thank you for your time, judges.
Thank you for your time.
Easy.